Let's next move over to the union. Union is a data type that is similar to the structured data type, but stores within it only one value at a time, so as to save space. It creates a group of different data types as a single entity, just as structures, but uses memory storage space of only one value at a time. Union is created by the keyword union, and it allocates just one memory space for all the declared values. The allocated memory has a size, which is the size of largest data type declared within it. Also, union remembers only the value that is most recently added to it, as newer values overwrite the older ones. Let's recollect what we had learned in the chapter on data types. Suppose that an office provides its employees with incentives of cash, grade promotion, or gift. Normally, an incentive can be any one of the option, at a specific time. Nobody gets all three incentives on a single occasion. So here, I declare a union data type that is capable of retaining any one value, from several possible other values. I name it incentive. We then declare a group of variables. Float. Cash, to store cash amount. Char, grade, to save office grade. And char, gift, to store gift name like Christmas card. Assuming that for Christmas we provide gift as the incentive, then we store plum cake to the variable gift. Similarly, at the financial year ending, we provide cash as incentive, and so we assign cash amount to cash. Note that memory occupied by the union named incentive is 50 bytes, which is the size of largest data type declared. When incentive is in grade, the union would occupy just 1 byte, out of the maximum of 50 bytes, and when the incentive is in cash, it would occupy 4 bytes, out of the total 50 bytes. So how does the system manage memory size in union? In a union, elements are of different data types. The data type with maximum size is identified by C++ compiler. In the example we had just seen, gift of type char is the one with maximum size, that is, 50 bytes. Hence, the total memory size of this union named incentive will be 50 bytes. However, if incentive was a structure, total memory size would have been 4 of float cash, plus 1 of char grade, plus the 50 of char gift, that is 55 bytes. Since all data in a union are referring to the same location in memory, the modification of one of the elements will affect the value of all of them. We cannot store different values in them, independent from each other. A union can unite an elementary type with an array, or structures of smaller elements. Let's look at an example. We defined a union named mix. We declare a long integer of size 4 bytes, a short integer of size 1 byte, another short integer of size 1 byte, and a character array of size 3 bytes. The union mix defines 3 variables. Long LG of 4 bytes, structure S of 2 bytes, and character C of 3 bytes. Since the largest size of declared variables is that of LG, total size of this union is 4 bytes, as represented in the given diagram. Since union stores only one value at a time, each of the data types declared in this union will use these 4 bytes quite efficiently. The long type data, max.lg, would use 4 bytes. The structured data type elements, max.s.sh1 and max.s.sh2, would use 1 byte each. And the character data type element, max.c, would use 3 bytes. Let's next move over to enumerators. It is a user-defined data type that can enumerate, or assign numeric values to a set of constants, defined within it. Enumerator activates only one value, from many available possibilities. Enumerator comes handy at occasions where we work with a set of related constants, or values, but need only one among the different options. It's defined by the keyword enum. Here, we declare the enum data type named score, which stores a group of values. Absent, fail, pass, distinction, and %. Note that each declaration ends in a comma. The last one need not have it. The variable absent is auto-assigned value 0, fail gets the auto-increment value 1, pass is assigned value 50, distinction is assigned 75, and %, is assigned value 100. During program execution, the enum is assigned with any one value from the set of given values. So here, if you use Enumerator to assign the score for an examination, a candidate can either be absent, or can fail, or pass with 50 marks, or have distinction with 75 marks, or can score 100% marks. Enumerations are type compatible with numeric variables. Hence, their constants are always assigned an integer numerical value internally. If it is not specified, the integer value assigned to first constant is 0, the next constant is auto-incremented by 1, and so on. We can also explicitly specify an integer value for any of the constant values, and the next value automatically increases from there on. In the example we just saw, absent gets default value 0, fail is auto-assigned the incremented value 1. However, pass is assigned an explicit value of 50, distinction is assigned 75, and %% is assigned 100. Here is an assignment for you. Using structure array, write a program to record the following fields of n students. 1. Student name. 2. Mark 1. 3. Mark 2. 4. Mark 3. 5. Total marks. Then, display a simple mark list. So now, we have completed chapter 11. In the next chapter we will look into functions. Until then, take care and have a nice time.